Hi kiddos, and welcome to our discussion of gas law stoichiometry. We're going to be taking this new material that we've been discussing in terms of the combined gas law and PreAP, and we're going to apply it to our previous unit, stoichiometry, and most of you really rocked at stoichiometry. So let's head into that. A couple of units ago, we used as a conversion factor the molar volume, that 1 mole of any gas at STP, and let me rephrase that, 1 mole of an ideal gas at STP is going to have 22.4 liters. Well, now we're going to be looking at non-STP situations. So let's take a look at the first problem. What you want to do first is make sure you write your balanced equation. You'll lose points if you don't write the balanced equation. So let's highlight the compounds that we are going to be dealing with. Hydrogen gas is collected. Because it's collected, there's a strong implication there that hydrogen gas is a product. And we take zinc and react it, and we love those words, excess HCl, because if it's in excess, we don't have to worry about it. Now, based on a couple of units ago, you should be able to recognize this as a single replacement, and zinc's going to steal chloride and make zinc chloride. Now, I've got to balance that, and there we go. We have our balanced equation, and that's a critical part to doing stoichiometry. Now, let's write our givens underneath. It asks us how many liters. It gives me a pressure of 750 torr. And then we have a temperature of 22 degrees Celsius. And you know by now we want to immediately convert that to Kelvin. And that's 295 Kelvin. Now, in this situation, we're going to take the dimensional analysis of a stoichiometry and we're going to then pop it into a formula. So this is really going to be 2 steps. Now, we may also, and my Mimio's jumping on me, sorry, we may also go from the formula into the dimensional analysis, but either way we need to do 2 steps. It's not going to be a complete dimensional analysis. Now we have 40 grams of zinc. Now I want to emphasize something here. The biggest mistake, I won't say the biggest, the most common mistake students are making is they see this mass and they want to substitute it into PV is equal to mass over molar mass RT. Now, that's a fine formula to remember, but we can't do that because zinc is a solid. This is an ideal gas law. So you've got to get to a gas via the mole road before you can pop it into PreAP. So our first step is to go mass to moles, and then we can go from moles of zinc to moles of hydrogen. And if you try to put a solid into PreAP, you're going to miss this mole ratio. Even if it's a 1-to-1 mole ratio, you have to show it. Now, once we have moles of hydrogen, then we're going to use this information and we're going to hop into PreAP. PV is equal to nRT. So let's run through this. I've got 40 grams of zinc. I'm going to use mass to moles. I'm going to use my molar mass from the periodic table. Remember, you can't put a solid into an ideal gas law. We've got to get to the gas. So that's 1 mole of hydrogen for every 1 mole of zinc. I'm looking for that mole ratio, even if it's 1-to-1. Now, at that point, we've got to stop our dimensional analysis. And we have this many moles, assuming our algebra is right, of hydrogen. Now, at this stage, we can plug into PreAP. So my pressure is 750 torr. My volume is my unknown. I just calculated my moles, and notice I've converted it to moles of the gas. Now for R, I use the R that has torrs in it, and that's 62.4. That's on your formula chart. 295 Kelvin. And if we solved and went to 3 sig figs, what we would get is a final answer of 15.0 liters. Whoops, there's that mimeo hopping. Sorry. Every once in a while, I think there's something electrical. All right. So that's one example. Now let's do another one very quickly. So this is the next one in your notes. We've got potassium chlorate. Oh, I cannot believe I did that. Shame, shame, shame on you, Dr. Leggett. Potassium is K, crazy woman, KClO3. It's a solid. Ionic compounds are solid, and there's no sign of water. So this is an ideal gas law. We can't put information about KClO3 or KCl for that matter into a gas law. We can only deal with the oxygen gas. So let's write our givens down. I have 7.89 grams of potassium chlorate. I heat it. You can put a triangle over that if you want. And the question is my volume, question mark volume, is it going to be greater than or less than 3 liters? Is a 3-liter container big enough to be able to collect it at 700 torr? I wish we could get rid of that unit, but even in the United States, the semiconductor industry still uses it. Now, notice that I immediately converted this into 298 Kelvin. Now, we can't jump into PVNERT until we get to information about our gas, because again and again and again, it's an ideal gas law, not an ideal solid law. So let's map it out. We've got to go mass to moles, and then we want to go moles to moles, and then we're going to have to hop out of the dimensional analysis to do the formula. So mass to moles, use molar mass, 7.89 grams of KClO3. Often, if you notice now we're giving you molar masses, you'll only have to calculate it once or twice on a test. And that's KClO3. Now, this is when I often notice that I have forgotten to balance my equation when I get to my mole ratio. And, you know, especially when I'm talking, I forget. It's where you're going to, I want 3 moles of oxygen over 2 moles of KClO3. Now I'm in the world of gases. And so the laws of gases, the ideal gas law, can finally apply. So 3 moles of oxygen. Sorry, I'm talking and writing and I'm messing up. KClO3. And if you do that algebra, we get 0.09657. I wouldn't bother rounding until we get near the end. So pressure was 700. My volume is my unknown. I plug in my moles of a gas. You can't use moles of a solid. Have I said this enough? Since I have torr, I'm going to grab 62.4 as my value for R and 295. Now, if I solve for this, I get a volume of 2.6 liters. So, yes, indeed, a 3-liter container would be plenty. All right, so, okay, I have a couple more of these I want to do. I want to work the opposite direction. So until then, this is You Got It. Haven't said this in a while. Love you guys.